Hi guys, welcome to this video about Boolean algebra. Boolean algebra is a branch of mathematics that deals with logical values, which can be either true or false. Boolean algebra is the important quality of digital logic and computer programming. It's used to design and analyze digital circuits, implement logical operations in software, and even study sets and logic in mathematics. In the word Boolean algebra, algebra stands for representation of problems or situations in the form of mathematical expressions. It involves variables like x, y, z, and mathematical operations like addition, subtraction, multiplication, and division to form a meaningful mathematical expression. One simple example of an expression in algebra is a plus b equals c. In Boolean, it refers to expressions that evaluate a condition and result in a Boolean value that is true or false. Boolean expressions mean the combinations of Boolean variables and operations, representing logical statements. For example, as a and 0 is equal to 0, we will see about this later in our video. Now, according to Boolean algebra, an algebraic expression results in Boolean values either true or false. Key concepts in Boolean algebra. Boolean variables are represented by letters like a, b, or c. They represent basic true or false values. The Boolean value true means a high value or 1. False means low value or 0. Boolean operations. The basic operations of Boolean algebra are as follows: conjunction or and operation, disjunction or operation, negation or not operation. These operations combine Boolean variables to create more complex logical expressions. In conjunction or and operation represented by a and b. This symbol represents the and. Sometimes this symbol is represented as a dot. It shows the rule that true only if both a and b are true. For example, we create a combination using Boolean values 0 and 1 for a and b. That is, 0 0. 0 1, 1 0, 1 1. If we solve the 0 0, where both are false, so result becomes false 0. In the second combination 0 and 1, show false and true, so the result becomes false 0. It is similar to the next combination. In the last combination 1 and 1, where both are true, so result is 1, because it follows the and rule that is true only if both a and b are true. Here this table is named as truth table. It refers to visual representations of how Boolean expressions evaluate for all possible combinations of input values. Next operation is disjunction or operation. This operation represented a or b. This symbol is named as or plus symbol. It follows the rule that true if either a or b is true, or both. It means if any one of the values becomes true, the result becomes true. In the true table, 0 0 are both false, so the result becomes false. In the next combination 0 1, where one of the values becomes true, so result becomes true 1. Similar for next 1 0 becomes true. In the final combination, both are true, so the result becomes true. The next operation is negation or not operation. It is represented by not a. This symbol is named as not. Also, it means that complement of a variable, represented by an overbar. Simply it denotes that flips the truth value of input. In the truth table, where true becomes false, false becomes true. This Boolean algebra has some law in build. Thus are and law, or law, inversion law, commutative law, associative law, distributive law, where and or inversion law uses the same operation which we previously see. In and law, the and operation is used to solve. It is performed by following Boolean expressions. a.0 is equal to 0. a.1 equals a. a.a equals ae. a. complement of a equals 0. Here the a value is 0 or 1. In or law. These laws use the or operation. Therefore they are called or laws. a plus 0 equals a. a plus 1 is equal to 1. ae plus ae equals ae. A plus complement of A equals 1. Next, inversion law. In Boolean algebra, the inversion law states that the double inversion of a variable results in the original variable itself. It is the double inversion of AE equals AE. Double inversion means if we assign A for true value 1, it flips to 0 and again flips 0 to 1. Next, commutative law. Commutative law states that changing the sequence of the variables does not have any effect on the output of a logic. Thus A dot B equals B dot A. A plus B equals B plus A. In A dot B equals B dot A, if we give A for 1 and B for 0, the AND operation gives the result as 0 is equal to 0. Here LHS is equal to RHS. Another law is associative law. It states that if a logical operation of any two Boolean variables is performed first and then the same operation is performed with the remaining variable gives the same result. The logical and logical or operations of three Boolean variables A, B and C are A dot B of dot C equals A dot of B dot C. AE plus B of plus C equals AE plus of B plus C. In first expression, if we give A for 1, B, C for 0, where A and B are 1 and 0. So, operation gives the result 0 as false. Those 0 and 0 become 0. Similarly in RHS, B and C are 0. Those 0 and 1 result in 0. That's it. The next law is the distributive law. It means that if all the logical operations can be distributed to all the terms present in the Boolean function, then the logical operation is said to be distributive. For this, A dot of B plus C equals A dot B plus A dot C. A plus of B dot C equals A plus B dot A plus C. Here A and D and or operations are distributed in one expression. In first expression, if we give A for 0, B, C for 1, B and C becomes 1. Next A or 1 results 0. In RHS, A and B are 0 and A and C are 0. So, 0 or 0 results 0. Boolean algebra theorems. Boolean algebra has two important theorems which are De Morgan's first law and De Morgan's second law. This theorem basically used to reduce the given Boolean expression in the simplified form. These two De Morgan's laws are helped to change the expression from one form to another form. De Morgan's first law. It is A dot B whole bar equals A bar plus B bar. This first law states that the complement of the product of the variables is equal to the sum of their individual complements of a variable. In truth table, the last two columns show the first law. De Morgan's second law. It is A plus B whole bar equals A bar dot B bar. This second law states that the complement of the sum of variables is equal to the product of their individual complements of a variable. In truth table, the last two columns show the second law. For example problem. Simplify A plus A dot B whole bar. According to De Morgan's first law, A dot B whole bar equal to A bar plus B bar. From commutative law, changing the sequence of the variables. From or law, A dot complement of A equals 1. And it becomes 1 plus complement of B equals 1. Therefore, A plus A dot B whole bar equal to 1. That's it. Thank you for watching this video. If want more like these concepts, subscribe to my channel and like this video.